Hello, kitties. It's me, and I'm lying on my back. Not really on my back, but almost horizontal. Oh, look at this funny curve I made just now. Bet you can't guess where A, B, C, and D are. But I swear to God, that's a loop. It's going around in the loop. I started here. Then I was thinking, I want to make a sharp corner here. And then I thought, well, what if this line cross, like this isn't on the curve, what if it just, the tangent is big and crosses the curve? What am I going to get? And I didn't think that you could make a loop with just those 3 or 4 points. You wouldn't believe the changes that I've made to this program. This whole thing, this for meat, it's no longer a window. See? It's a reg. It's got a WinProc though. And see, the reason for that is I don't really want to stop it. I'm going to have to. I can make another one. The reason is, that's probably too high. Although it would take time for them to release themselves. The reason is I gotta destroy the whole window and rebuild it again if I want to go to full screen mode. Here's my, I don't know if it still works anymore. My demo. Don't think I broke it. Too bad. Right, it's hack after hack after hack. But I just wanted to ensure that it's possible. So I can do these things. It's just probably luck that it doesn't always erase. But anyway, this is full screen, see? And it's drawing the words at the right place, so it's calculating the coordinates, okay. But and invalidating the whole rectangle. It's clipping fine. Well, I'm not doing anything special to make that clip, right? The window size is the whole screen area, right? But the underlying device context only covers, when expanded out to this size, this amount. So that automatically gets clipped. Also, let's put it on a funny cursor. Look at that spinning one. See how that happens like that? Well, I'm not doing that on purpose, right? But I have somewhere in my handling that if I get a message and it's not within the client area, then I turn the cursor back into an arrow. This is what it considers to be the client area. In fact, in this size, the client area is all of this. I had to paint this black part in order to hide the background. Like Alt Tab. Let's see. Oh. Oops. It's kind of difficult to demonstrate. But anyway, oh, sorry, I gotta show you the other thing. I went to full screen there, that, in my thing, and I can also go back. And the way that works, where is that? See, eventually I made it. The members, I was trying to find a way to transfer the member data that survives from one Windows struct to the next, right? Over a change in destroying the entire window and then making a new one. I don't want to destroy this data, which has these things in it. This isn't copyable, so I can't copy that. I have to just maintain it. All the rest actually could be copied, but I just decided to make it global. And so here's the loop. While changing modes, now I have this function called create, which takes an atom, two different atoms, full screen one and Windows one, and send it through its message loop, okay, and then delete it. And then if we're not changing modes, this is a boolean I'm supposed to set before dying, then continue on, make a new one of this kind, update, show, let it go through its message loop, delete it, loop back here, and check again. So I'm always deleting and recreating these windows. And I thought, well, the reason that was such a pain was because this thing, the program here itself, like window prop here, is a member function of both either one or both of those classes. But both of those classes, my window is the windowed version, and then full screen derives from the other. So they share some of the same wind prop stuff, right? Like this one calls the other wind prop. But then there's a difficulty with scaling, and you gotta be careful. But anyway, it works. You saw it work. But if I want to get rid of that headache, right? Just don't be a window. Just have the window for meat here has a pointer to window here. There would be two, but I wanted to test to see if it works. First with just one as a member, okay? And now everything else is essentially the same. It just thinks it's a window. Everybody thinks it's a window. And, you know, I make this function calls, you know, the member variables version and so on. And they're all a big happy family. They're all friends, and everybody's friends with everybody else. Well, it should be. If I was going to derive from this class, then you know, we should be on good terms. I would think good enough terms to be friends anyway. Similarly, you know, although this one didn't previously have access to stuff it couldn't know about, now it does. But no, that's perfect, it turns out, for timing and getting all the pointers right at the time when the creation occurs. So here's the window to view, create call. Given an atom, given a pointer to essentially the application. It's starting to look like MFC, isn't it? I have a window frame or a view window, and this here now is not a window, it's an application type object, and H instance. From that, I create, using new, one of these window type things, and set its style like that. This is, there's the regular windowed window, overlap, sysmenu. How can I get all that? Anyway, well, actually, I want some more. I want to have a maximize box, so I can do that. Anyway, now that returns a pointer to window, right? And I thought that would be a good time when it returns that to assign my member variable to the returned value. Now what do I call that? Name go. In the constructor something. Really early on. See now. No. It must be in go. It's in go. Right. Create, yeah. See here, previously I was assigning this here, P curve view, on this line. That's too late. By the time that assignment gets done, the program would crash. Because create calls into WinProc. See? Not my WinProc, mind you. This one's WinProc. And he's fine. But his WinProc calls my WinProc. See? Down at the bottom. Here's the implementation for window view. Frame window proc. Well, before it was just this. Call, it has a pointer to the application. Call WinProc. Okay, but that's too early because this object hasn't yet obtained this member. But also, I have this global, I don't know if I need it, but I have this global around that contains, it's supposed to contain previously a pointer to the window. But now it's not a pointer to the window or anything, it's a pointer to the Hermite thing, which is an app type object. Well, that thing happens to be just the member that was passed in here. So this object already knows about that. So before WinProc gets called, this guy can set up all the pointers to make sure that nothing's null, and call the WinProc and everything works fine. And some overrides are called here. And so in almost every sense of the word, this app is behaving like a window, as a WinProc. Although it doesn't have I don't gain all the functions I would get by deriving, like these ones. So I have to forward them through. That's no big deal. Now, but a lot of the work here that I've been doing, you see all these functions. This is I guess one of the simplest versions of what you would call a state engine. the state engine. In particular, this has only to do really with the edit. When you're in the editing mode, there are various types of editing that you can do, and the variables were getting mixed up and not cleared out properly or not initialized right. So I realized I had to take the time and sit down and write a real state engine for the editing thing. Now the way most of these state engine things work is you have, these are like the states, okay? No state. This here is a waiting state. This is required to give, when you want to let the WinProc do normal processing while you're waiting for something, like if you run a dialog. Okay, then there's the three states: drawing a path, drawing vectors, or the alert thing. And so when you enter into one of these states, you call a function called set edit mode, right? Usually, like in our games that we had a similar thing. Every state would have like a on enter like this. Begin. The function's name would always be begin or start or whatever, and then the name of the mode, right? Begin mode, right? And then the mode you're coming from, because each one has a function, has to have a function with the naming convention leave in this case. So if you're in one state and you're going to another state, leave for the current state gets called, and then begin for the next one gets called, and hopefully that everything stays in bounds. But we always used to pass in, when entering a state, was it either the previous state or when leaving the state, what the next one was going to be, one way or the other. You knew that, so you knew the direction, but I don't seem to require that in this case. It's simple enough so far. So yeah, all this function does is if the mode changes, then call the leave for the last mode, and then call the begin for the next mode. So one example is this. When I'm leaving the vector state, I clean up the clicks that I'd saved, clean up the vectors that I'd saved, clear out the functions that I added, and so on, and re-enable this menu item got disabled. This is a sub-menu, turns out. And then if I'm entering this state, I enable this menu item, so you can go from here to the alert, and I disable this, so I can't jump from vector editing to drawing points. See what I mean? I can exit, but I can't go that way. And then I set up the colors that correspond with this state. It's a very simple concept, but it's tedious to write all these down. And you end up with, it's kind of good though, because what you end up with is, for every state, you make a file, a separate file corresponding to that state. The design forces you to do that. It's the natural thing to do. And now it's very easy for me to find everything. All the files are small, right? They only have a few functions, right? And instead of having one great big file, I have a few small files, and it's very easy to follow the code. Even this LERT thing, which is quite big, is not that bad. This has a sub-state within it where it's doing the automated playback, right? Or not playback, but random generation of points. And that is a 5-stage loop, and it's sort of keeping track of that as well. Not important. It all works, and I should be able to add full screen. Now that I've proven that I don't actually need to be this object doesn't need to be a window. I just gotta get the full screen going. I don't need the menu or the menu items in full screen. I'll just make keyboard shortcuts for things like enter and leave edit modes. I could make them the same as the. I could still use the accelerator table. Turns out, I don't think there's any restriction again saying you can't. See, this thing uses an accelerator table in its message loop, but this accelerator is a resource that has nothing to do with the menu. It's independent. These are independent. Okay, like this generates command messages, and this also generates command messages, and it so happens that some correspond with the others, but that doesn't mean that if I got rid of this would still generate its messages, and vice versa. So I could keep the shortcuts I already have, they would work. And there was a lot of work that went into all the little changes and things in common, especially this geometry.h is becoming a monster. Actually, there's a lot of these new functions I can get rid of. So one of the things I added was to do that flip. Well, I can do the flip if I add matrix multiplication. So now I can multiply vectors by matrices. So I don't need a special thing to flip the y-axis. The program itself, although it looks quite complicated, it's simplified significantly by some of the functions I pained over getting correct. Like, what's that function? The one I'll call all the time. Client to something. Alright, here. There's really nothing to this function, right? But this was where I kept getting messed up with this program. When adding things to it, I would always get the positions wrong, right? Well, A, because there's a flip, and then there's it's another coordinate system with an origin here rather than here, right? And what I was always making the mistake of subtracting this point from things. This point is here, it's at position 616, 435, indicated here, right? In order to find out what its position in this Cartesian coordinate system is, I don't subtract this thing, right? I've got to subtract origin from origin. Like, I take this origin, subtract that origin, okay? Now that is, physically, that would be like moving this point somewhere like here, right? So 196 and 136, right? At that point, that's the same as if I place it here, see? It would be correct if the axis was reversed, it would be at the correct spot. But at this point, I can flip it. So you gotta do it in the right order. First, you subtract origin from origin, which brings you here. I'll show you. It's going to be exactly right. I'll put a dot. Okay, right here. This dot is at 202 minus 128. Now, if I subtract the origin, whose position in inclined coordinates is 400, 300. So take this, subtract 400, 300. That gives me 202 and 127, 128, right? 202, 127. Whatever. That's where it's going to be. Like that, wherever it is. But that's its coordinate, right? That's its Cartesian coordinate. Cartesian. I'm so dumb. I was wondering, is that what the y of x, is that called Cartesian? And it just struck me. Yes, of course, that's Cartesian, named after the genius and philosopher Rene Descartes, who invented this system of x's and y's. So that's why they call it Cartesian. It's the Cartesian for Descartes. Anyway, no, why not? Just for fun. Now that I'm using a state engine, I should be able to get to my thing and it'll work. Let's see if we make another loop. I go now. Start here, I go way out far away, and I'm going to make something highly acute like this, and then a long tangent like to here. Boy, I want to press Alt-Enter and make that full screen. At first I couldn't figure out what the hell was going on. It looked like it was, a bug. But actually that one's not a loop. See, it's able to do it by going up. And the other one might not have been a loop either. Can I start over again? I should be able to. Oh no. No, something I forgot to clear out. But it'll be easy to fix with now that it's all properly organized. So the problem with that one was it was able to do that. So if it's got to come back a long way and maybe go this way, it wouldn't be able to. And then was it long? How about like this and this? I don't know what it's going to do. The only way to tell for sure is to compute it by number and watch the motion. This is something that looks like it might not be this side. I don't know if that is at all. Most points are winding up there. Look at that. What is it? Is that a loop or is that a kink? It doesn't look smooth. I would try adding another control point. Allow selection of control point. See what happens. But even just with 2, I guess, weirdo things can happen, obviously. Now that is weird. And this program is not a window anymore. It's a window watcher. It creates a window, and that window acts like a notifier. In a way, it's no real difference, I guess. But it's just that I don't want to destroy all the other data when I delete the window. All this data, curves and stuff. I want to do Alt Enter while it's drawing the curve and not lose anything. Right? And not have to make it a global variable. No, that's pretty cool. And there's something in there. See, I didn't clean that up properly. But I can see the bugs. Alright, see you. What am I gonna do next? Oh yeah, finish full screen and then on to the next topic. Okay, well nobody watched the last two, so I guess nobody watched this one either.